Alright, welcome to the second of 5 videos in this particular lesson. We're going to take the concepts that we discussed in video 1 and we're going to take those into problems that are going to require more than just one step and that might take 2 steps to solve. So when we're doing a problem that involves more than one step that we're solving an equation with, the first thing we always want to do is identify what operations are being done to the variable we're trying to isolate. So we want to figure out what 2 different things we're doing. And then we want to use the inverse of each operation to undo it, just like we did with the one variable. The one step. The important part when you have more than one step, though, is to figure out which one you need to undo first. And we'll give you a hint. Since you are working backwards to solve for the variable, you're using inverses to undo things. You will want to figure out that you are working through the order of operations backwards. So one thing that I always like to do when I'm working on solving problems is I like to write my little acronym GEMS, like we talked about in lesson 1. And I would like to just draw an arrow going the other way at the top of my paper. This reminds me that instead of going my normal way, doing grouping first, then exponents, then multiplication and division, and then subtraction and addition, I want to undo things going backwards. So I want to undo any subtraction or addition first, then any multiplication, then any exponents, and then any grouping. Alright, so we have 2 examples we're going to go ahead and jump into. We have 3x plus 4 equals 14. So the 2 things that I am doing in this problem, I am multiplying the x by 3, and I am adding 4. So if I'm going through the order of operations, I would normally do multiplying before I do addition, but since I'm working backwards, I need to undo that addition first. Remember, the inverse of addition is subtraction, so we want to subtract 4 from both sides. That will give us 3x is equal to 10. Alright, and then our last step is going to be to undo that multiplication, and to do that, we're going to divide both sides by 3. So we're going to get x equals 10 thirds because 10 does not divide evenly by 3. Now in high school math, we're completely fine with improper fractions. You do not need to change this to a mixed number. We are fine with this answer right here. Now, one thing I want to point out with this is sometimes you get answers that are not whole numbers, and that's okay. We do not always get pretty numbers in math. Sometimes we end up with fractions or decimals, and that is completely okay. So a lot of times students will freak out if they get a fraction as an answer, but remember, if you plug this back in and it all works out, then your answers are going to be correct even if they look a little bit funky. So for example, if we plugged it into this problem, if we did 3 times 10 thirds plus 4 equals 14, the 3's cancel here, so we would have 10 plus 4 equals 14. 14 definitely equals 14, so we know even though we got a funky fraction, our answer is correct. Alright, let's look at example number 4. It's going to be a little bit tricky. Now notice we have a fraction. We have y plus 4 over 3 is equal to 9. Now what this fraction bar does is something that's a little bit unique. What this fraction bar does is it groups everything on top and then it groups everything on bottom. So this is really like we have parentheses around that y plus 4. That fraction bar lumps that together so that we can't separate those just yet. Normally we would want to undo that addition first, but since that fraction bar puts this in parentheses, this actually falls under the grouping category, so that's going to be what we have to undo last. So the other thing a fraction bar means is that we're dividing. So to get rid of that division, what we would need to do is multiply. We multiply both sides by 3. Alright, now, the whole reason we do this is to cancel things out. So a 3 on top and a 3 on bottom are going to cancel out, and we'll just be left with y plus 4. One common mistake that people will do is they'll cancel out that 3 on bottom, but they'll want to multiply the top and get 3y plus 12 and distribute that 3 out. We do not want to do that because our 3's are taking care of each other. So we get y plus 4 is equal to 27. It was like we had parentheses around these. we've dealt with it. It's all by itself now, so we can subtract. We undo the addition by subtracting 4, and we get y is equal to 23. If we plug this back in and check, 23 plus 4 divided by 3 should give us 9. That's 27 divided by 3 equals 9. 9 is equal to 9, so we have the right answer. Alright, you guys go ahead and attempt these you-try problems. I will give you guys a little bit of a hint. Pay attention to how the fraction is written. In this one, it's like we were talking about before, and that fraction bar groups the 10 and the x because they're both over the fraction bar together. But if you look at example 2, that 5 is not grouped with the p. Alright, I'm not going to give you anything more than that. I trust that you guys can figure out how to work these two problems, but I did want to just give you guys a little heads up on that. Alright, we'll see you in the next video.